Hello, welcome back to Math 8. This is the first video of Unit 6. We're going to be working with exponents in this unit, okay? And we'll talk about powers and exponents, and that's what this section is about, Section 1. Our objectives today, we want to express a power of a positive integer base in expanded form. We want to express expanded form in exponential form. We want to evaluate powers using fractional and negative bases. Blah. Okay, so basically, let's talk about what an exponent is, okay? And we have this down here with an exponential form, but I want to write it up here. An exponent, and I'm just going to draw an arrow here, exponent, is the little number above the big number, okay? All right. And this, what this does is it shows repeated multiplication. Repeated multiplication, all right? And so that's what an exponent does. An exponent determines, so let's write this. The little number tells you how many times to multiply the big number. Okay, and that's all you're doing, okay? So what I want to do here is to show you the difference between exponential form and expanded form. Okay, so let's say that I am multiplying 10 6 times, okay? And that's what I'm doing here, all right? So you are multiplying 10 6 times, okay? So 10 by itself 6 times. Okay, you're not doing 10 times 6, you're doing 10 times 10 times 10 times 10 times 10 times 10. So what I would do then is I can then write that in exponential form. So I don't need to write this out, okay, because it's going to get really long. But what I can do is I can say that this is 10 to the 6th power, okay? So when I write this, this phrase here means 10 to the 6th power, okay? And so what I have here is that 10 is the base and 6 is the exponent, okay? And again, the base, we'll call this the big number, okay? And 6 is the little number, all right? The exponent is the little number, all right? And so again, that tells you, 10 to the 6 means you're multiplying 10 6 times, okay, by itself, okay? And so that's what we got, all right? So we can evaluate this, okay? And so on this, it wants us to determine the base and the exponent. So on this, number 1, okay, we've got the base is equal to 3, and the exponent is equal to 4, okay? And I want to express this in expanded form. So if I've got 3 to the 4th power, all right, I can really write that as 3 times 3 times 3 times 3, okay? And what it wants us to do is evaluate this to see, okay, if I multiply 3 by itself 4 times, what's that number going to be, all right? And so what we want to do is we want to do this repeated multiplication. Now, in your calculator, you could simply just type 3 times 3 times 3 times 3 and do that. On paper, I would do this. I would multiply these two numbers first. 3 times 3 is going to give me 9. I'm going to drop down the other numbers, times 3 again. 9 times 3, that's going to give me 27, and times 3 again. So 27 times 3 is going to give me a value of 81, all right? And so this is evaluated, okay? And so, what I could then write is that if I say 3 to the 4th power, that is the same thing as me writing the number 81. Okay, so we can actually evaluate this, okay, and get an actual number, all right? So, that's the idea. That's what we're doing, okay? You're just multiplying the base by itself the number of times the exponent tells you, okay? So integer base versus variable base. So what we want to do is you've probably seen this stuff before. Maybe it's a little bit of a refresher for you, but what we can do, and this is the jump that we're going to do in algebra, okay, is we're going to talk about a power with an integer base, okay, where your base is a number, okay, or where your base is a variable, okay. So this is the jump that we need to make, okay, and we need to start doing things and using this with a variable, all right. And the same thing applies, all right. If I have 4 to the 5th power, that's 4 times 4 times 4 times 4 times 4. I'm multiplying that number 5 times by itself, okay? If I talk about this with a variable, all I'm doing is I'm taking m, this number, and I'm multiplying it 5 times. So m times m times m times m times m, 5 times, okay? Now this you can't evaluate, okay? You just leave it like this. Now if you have a number raised to a power, you can do the math and evaluate, all right? And so if I do 4 times 4 times 4 times 4 times 4, 1, 2, 3, 4, 5, I get 1,024. So, these numbers get really big. 4 to the 5th power is really just 1,024, okay? All right, and so that's the idea. All right, so, the other thing we want to do is we want to be able to write this in exponential form. So we want to convert the expanded form into exponential form. So here, what I'm doing, let's do this with integers, all right? If I have 8 times 8 times 8 times 8 times 8, okay, I am multiplying 8 by itself 5 times. So let's write that. Multiply 8 by itself 5 times, okay? And what I'm going to do is I'm really going to write this as just 8 to the 5th power, okay? I could evaluate this if I wanted to. 8 times 8. And this is going to give me a value of 32,768, okay? So really this is the answer, but you can evaluate that, all right, because you have integer bases. If you have a variable base, you can't do that, all right? And I'm multiplying p by itself 4 times here. So I'm just simply going to write that this is p to the 4th power. But I can't evaluate because I don't know what p is. All right, I just leave it like this. All right, so instead of expanding this out so far, okay, we can condense it down and write it in a simpler form. Okay, all right, that's the idea for that page. Let's take a look at the back page. Okay, so on this one we have something different. We've got powers with negative bases. Okay, so we're going to extend this idea out, and let's do this. Now I want to determine the base. Okay, the base, number 1, the base is -6, okay? And my exponent is, what is that, 3? Yeah, 3, okay? I want to express this in expanded form. So what I'm doing here in this is I'm really writing this as -6 times -6 times -6. Now when I do this and use parentheses like that, that means I'm multiplying, okay? And so what I want to do is then evaluate this, okay? So something that's unique about this is that if I take -6 times -6, that's going to give, that's a negative times a negative. That's going to give me positive 36, okay? Now, if I drop down my -6 and multiply that, I have 36 times -6, and a positive times a negative is going to give me a negative. So this is going to end up giving me negative 216, okay? And so, that's what we've got, all right? So this whole thing here is equal to negative 216, all right? Now, what I want you to notice here, powers with negative bases, the negative base is always in parentheses, okay? That's a big thing with this. and I want to show you something. If I do, so let's kind of look at another example here. If I were to do, say, -2, let's not do -2. Let's do -4. -4 squared, okay? What I'm doing there, because I have my negative symbol inside of the parentheses, that means I'm squaring the negative, all right? And this is going to give me -4 times -4, which is going to give me a positive 16. Okay, now if I do this, if I write -4 squared, okay, you have to understand here that I'm not squaring the negative here. Okay, what this means is that I have really -1 times 4 squared, which is really going to give me -1 times 4 times 4, all right, which is going to end up giving me a -16, all right? So it's important, parentheses are your friend, all right? Use them. And if you see this and this, they mean two entirely different things, okay? The negative is on the outside, and you are simply just squaring the 4 here, all right? So make sure that you put these things in parentheses, especially when it comes down to using a calculator. It's really important that you use the parentheses when you're evaluating your exponents, okay? So let's look at some patterns here, all right? So what I've done is I want to talk about, I want to square -2, square it, okay, raise it to the second power. Take -2, raise it to the third power. It's also known as cubing it. -2 to the fourth power, -2 to the fifth power, okay? And so what I want you to look at here is, and notice that the base is the same. The base is -2, okay? But what is changing in this table is the value of the exponent, okay? So we've got an exponent of 2, 3, 4, and 5. Now what I want you to look at here is that notice that, the exponent here is even. Here, the exponent is odd. Even exponent, odd exponent. All right, and here's our expanded form. Okay, so we don't have to do much work. We're just going to figure out the value here. So now if I take -2 and multiply it by itself twice, negative times a negative is going to give me a positive 4. Okay, now if I do this 3 times, okay, what's going to happen is I have -2 times -2, which is going to give me a positive 4, times a -2, okay, and that's going to give me a total value of -8. Okay, so I have -8 here, all right. Now if I take -2 and raise it to the fourth power, all right, what I'm going to get is -2 times -2, which is going to give me a positive 4. -2 times -2 here is also going to be a positive 4. So I have 4 times 4, which is going to give me a value of 16. And when I multiply two negatives together, I get a positive number. These two negatives give me a positive number. Positive times a positive is going to remain a positive. Now if I do it 5 times, okay, think about what happened. Now we've already evaluated -2 multiplied by itself 4 times. Okay, that's going to give me a value of positive 16. Okay, so I have 16 times then another -2. A positive times a negative is going to give me a negative, so -32. So what we can conclude here is that if you raise a negative number to an even power, okay, your result is going to always be positive. Okay? But if you take a negative number and you raise it to an odd power, you're going to get a negative value out of that. Okay? So that's something that, understanding this power, or understanding this pattern, is crucial down the line. Okay, and it's something that I'll continue to talk about. However, understanding this pattern and seeing this is really crucial. Okay, let's talk about powers with a fractional base. Okay, so what I want to do is this. If I'm doing this, the only thing that's changing here is just the fact that my base is now a fraction. Okay, nothing else. I'm still taking this number and I'm going to multiply it by itself 3 times. So here's what I get. I can write this as 2/3 times 2/3 times 2/3. Okay? And when I evaluate and multiply fractions, I simply just multiply across. All right? And so if I do this, I'm going to do 2 times 2, which is 4, times 2 again is going to give me 8. Okay, 3 times 3 is 9, times another 3 is going to be 27. Okay, and that's all I'm doing. All right, so same thing as I was doing, except for we have fractions. All right, now we can also have negative fractions too, and that's okay. All right, so let's do that. All right, I'm going to expand this out, and I'm going to write negative 1/2 times negative 1/2 times negative 1/2 times negative 1/2. Now, if you sit here and realize I have a negative number raised to an even exponent, okay, this means that I'm going to have a positive result. Okay, if I take negative 1 times negative 1, that's positive, times negative 1, negative. So negative number times another negative number is going to give me a positive. So this is simply just going to be 1 over 2 times 2 is 4, times 2 again is 8, times 2 again is 16. This is 1/16, okay? And you can do that math, okay? So it helps to expand these things out. Don't feel like you have to, simply just try and do all this in your calculator or in your head. It helps to actually expand them out to understand exactly what you're doing, okay? And we'll learn other rules down, later in this section to talk to you about how this works, all right? Okay, last part here, we want to write each algebraic expression using exponents, okay? So these are expanded exponents here, all right? And so what I want to do here is take a look at this first example and look at the fact that I have multiplying 2's and then by 6's, okay? So I'm multiplying 2 by itself 5 times. 1, 2, 3, 4, 5. I'm just counting them, all right? So I'm going to write that as 2 to the 5th power, and then times 6 times 6. Okay, so times 6 squared. And I'm just going to leave it like that, okay? Now, you could certainly evaluate this and multiply all these numbers out. I'm not going to do that right now because that's not what it's asking me to do, okay? But you could put this into a calculator, do it by hand, whatever you want, but put those in there, okay? Let's take a look at this one. Now, this one, I've got a variable here, and I've got -5, all right? So what I'm doing is I'm taking a, and I'm multiplying it 3 times. This is going to be a cubed. All right. If I have -5 and I'm multiplying it by itself 3 times, then I would write that as -5 quantity cubed. All right. And that's it. I'm just going to leave it like that. All right. So we're kind of blending a couple of these ideas together. Okay. Whoop. Something happened. Okay. And so now I've got all these. Okay, and I've got, let's reorder this, okay? And when I multiply things, I can reorder them. So I'm going to do this. I'm going to do P times P times P times 1/5 times 1/5 times a -s, okay? And I can write this in exponential form, okay? I can write this multiplying P by itself 3 times, so I can write this as P cubed, multiplying 1/5 by itself twice, so I can write this times 1/5 quantity squared to the 2nd power, and then multiply this by -s, okay? And I would simply just leave it like that. Now, you can reorder this and put things out front, and usually do -s times P cubed times 1/5 squared. However you want to do it, doesn't matter. But know that you can reorder when you multiply numbers. Okay, so that's all I got for this video. Hopefully you enjoyed it. And we'll talk to you soon. See you later. Bye!